In this video, we're going to look at how to perform sequential processing using the Tabular Data Calculator tool in RAMP. Let's start that tool and have a look. So here is the Tabular Data Calculator tool, and you'll notice that there are two types of processing that you can perform with this tool. One is sequential processing and the other is in-memory processing. We're going to focus in this tutorial just on sequential processing. What that means is that the input tabular data set is read row by row, and you can perform a calculation using any field within that current row. So that's very similar to the field calculators that you might see in QGIS or ArcGIS, for example. So let's go ahead and choose an input data set. Okay, I've chosen an input data set, and you can see here that it's listed all of the available value fields in that tabular data set. In this particular case, this is a navigation data set that we previously exported from a EM Model 302 multi-beam echo sounder. So it contains the position of the sensor, and it contains various other useful information such as the speed of the sensor, the course over ground, or COG, and the heading of the sensor. So for this tutorial, we're going to use this data to calculate the difference between the heading and the course of the sensor. And this will give us the amount that the sensor is yawing. And in multi-beam echo sounder data acquisition, yaw is something that we would like to try and avoid as much as possible. So by calculating the yaw, we are going to produce a field that tells us something about the quality of the data that we're acquiring. So if we have a look at the data set, you can see the latitude and longitude as I pointed out earlier, and you can see the course over ground and heading, and you can see indeed that those two values are different. So going back to the calculator, let's look at how we might define our calculate function to input the heading and course over ground and take one away from the other. So first off, the calculate function here is implemented using the C# programming language, which is a part of the Microsoft.NET framework that RAMP is built on. The most important thing is the signature of the calculate method or function. It has to be public scope, and it must be statically defined. If you don't know what that means, it doesn't matter. Just make sure you don't delete them. You'll also notice that it returns a string. So when you calculate something using the Tabular Data Calculator, you must return a string. And the reason is that the calculator is defined to be generic, such that you might return a string that says OK or not OK, for example, or you might actually want to return a numeric value which just happens to be serialized as a string. The second or the third thing to note is that the calculate function must be called calculate. And within these brackets is where you can define which of the available value fields you want to use in your calculate function. So these fields that go in as arguments to the calculate function must have the same name as the fields in the input tabular data set. So in my case, I want to use the heading and course over ground fields. So they are likely to be double precision values, so I'm going to declare them here as double and then heading. And you'll notice that the Tabular Data Calculator has highlighted the fact that heading is now used in the function method. Let's go ahead and also declare course over ground. And again, it's highlighted the COG or course over ground field as being utilized. If I was to now define something that doesn't exist, so let's say int or string name, you'll notice that it's telling me in warning that, hey, you've declared something in the arguments to the calculate function that doesn't actually exist in the input tabular data set. So that's useful. I can say, okay, yeah, there isn't something called name. Let's get rid of that. We're only interested, of course, in heading and course over ground. So I should mention that you can define the type of the input field to be either string, double, float, or int. And the ramp tabular data calculator will take care of the type conversion for you. The other thing to make mention is, of course, that in order to be declared as variables, the name of the value fields have to be compliant with the C# programming language requirements for variable naming. So when you add the input tabular data set, it lists all of the available fields that have names that are compliant. If there is a field in the input tabular data set that does not have a field name that is compliant with the C# naming conventions for variables, the calculator will tell you and it will warn you, and then it won't include that field in the available fields listing. So you could always go back and rename that field using a text editor, or in fact the tabular data processor method called rename_field. That would work as well. So let's go ahead now and do a simple calculation. So I'm going to declare a variable called delta h, that's my change in heading, and it's going to equal the heading minus the course over ground. Very simple. And I need to remember to return a string, so I'm going to return the delta h variable that has been converted to a string using the inbuilt toString method for the double type. Okay, let's go ahead and run that and see what happens. But before I do that, I have to define an output file. So output.csv, and it's asking me, well, what field name do you want to call whatever you've calculated? So I'm going to call it also delta h. Let's go ahead and run that and then look at what that output file looks like. Okay, in my output file, I can now see that I have a delta h field and the values of course over ground minus heading, or sorry, heading minus course over ground. Some of them are negative values and some of them are positive values. So what I think we want to do next is we want to actually return the absolute value of delta h. And we'll look at how to do that in a second. So to make use of the inbuilt math functions in the .NET framework, we can actually call them by declaring the full namespace. So system.math.abs calls the inbuilt absolute value function in the system namespace. If you're not familiar with what all this is, Microsoft has kindly given us a whole suite of functions that are put into what are called namespaces, and I just need to declare the full namespace. So the ramp calculator can access anything within the system namespace. So let's go ahead and run this now. We should have the absolute value of what we calculated. So calculate. Let's go and have a look at the file. And sure enough, now I have positive values for delta h. I want to do one more thing. I think it would be useful for us to be able to classify maybe the quality of the ping at this particular position and time based on how severe the delta h or the yaw value actually is. So let's look at how we might do that in the calculator next. So I'm going to use this as an example of how you can define multiple functions within the code area in the calculator. So I'm going to declare a new function. Now it must be public scope and it must be static, but it can return anything. In this case, I'm going to have it return a string, and I'm going to have it called classify yaw. And as input, it is going to take delta h, so we'll call it yaw. Yep. Okay, and this is going to use a series of if statements. So if yaw is less than or equal to 0.5, then return OK. And then we'll say else if yaw is greater than 0.5 and yaw is less than or equal to let's say 1.5, or let's say 2, then return, actually we'll call this one okay, return okay, and then we'll call this one good. And then we'll say else, so this is now anything that's greater than 2, return the word bad. Okay, so now I can call this function from my calculate function. So remember, you must have a calculate function before the Tabular Data Calculator tool to work. So I'm going to call it here. I have a double delta H, which I'm going to pass as a variable now called your into my classify your function. So return classify your and give it delta H. Classify your returns a string, so that's okay. A string will be returned from the calculate function as well. Let's go ahead and run this now, and we will call this field instead, we will call it your severity. Let's run it and see what happens. So you will notice that it's now added the your severity field, and it's classified the calculated your based on the criteria that we had provided it earlier. I just want to go back now and look at our calculator function code and talk about how to use exception handling. So you might want to use exception handling in your code. Let me, to clear this up, let me get rid of this second function, and we will go back to returning delta H to string. So if you're very confident that your input data is good and it can be cast into whatever you asked it to be cast into here, and that your logic is absolutely flawless, you might not want to have any exception handling. So if something goes wrong, or so you're assuming something isn't going to go wrong. However, it's good practice to put in exception handling into your function, and there are two ways of doing that in the RAMP Tabular Data Calculator. The first is to just return a default value or an out of bounds value. So in this example, I have my try, do some stuff, catch. So this is if an error is thrown, catch it, and just return, maybe instead of a -999 value, we might return the words error, for example. So that's one way of doing it. I can choose to return an error value or an out of bound value. The other way to do it is to throw a new exception. So what I might do is I might catch the exception and then throw it again. Okay, if I throw an exception in the Tabular Data Calculator, what this means is that that row will be excluded from the output file. So there are your two main ways of dealing with exception handling in the Tabular Data Calculator. The first is just return an out of bounds value like -9999 or the word error or something that's noticeable like that, so that you can go and have a look at those records in your output file and understand perhaps why it didn't work. Or you can say, doesn't matter, throw an exception and completely exclude that row from the output file. So that's exception handling using the Tabular Data Calculator. Let's go ahead now and look quickly at something that's a little bit more advanced, and we're going to go to the help documentation for that, and that is calling external assemblies or libraries within your code. So let's have a quick look at how to do that. So the RAMP documentation for the Tabular Data Calculator shows you how to do this. You need to use the system.reflection library or assemblies in the system.reflection namespace in the .NET framework to load a DLL from file. Then you need to get from that file the assembly location, so that's namespace and class within that DLL file, and then you need to create an instance of that, and then you need to get the name of all of the methods within that class, and then you need to populate the arguments to those methods and then finally invoke them. So it looks a little bit complicated. For those of you who are familiar with Reflection and .NET programming, this might not be too much of a concern for you. So it is considered a advanced method, but I wanted to show you this to prove that it is possible, in fact, to call external libraries from the RAMP calculator. So this has been a quick introduction to sequential processing using the Tabular Data Calculator tool. And in another video, we're going to look at the in-memory processor. But I hope this has been of use to you. Thanks for watching.